Alright, I'm going to try to go through this review sheet fairly quickly, so the video is not 8 hours long. Okay? Alright, so rewriting this is x times y to the 1/2. So again, there's other ways to write this. When you expand, there's 1 log for every variable. There you go. So you could distribute that 1/2 in, or you can leave it. Same deal with this one. Okay, this is the log of x, y, z to the 1/2. So the 1/2 can either go out front with them all, with a parenthesis, or plus 1/2 log z plus z plus 1/2 log y. Oh, I screwed up the order of z and y, but that doesn't matter. Yeah. This order here, the z and the y, don't make any difference, as long as they're both positive. So condensing logs, they all go together. Z, x to the 3rd. Okay, and then this this y to the 5th, this is a minus sign, so y to the 5th goes on the bottom. That's a 5. Okay, you can distribute in that 6. Or you can just make it one giant exponent. So it's the ln of z to the 6th, x to the 36th, and y to the 6th. This one here, we have a log. Remember, we're condensing, so it's all going together. This is positive, so z is on the top. Negative, x goes on the bottom. And positive, y goes on the top. So I just did a little accordion business here. Made you expand and condense just to get used to kind of doing them all. So remember, when you're expanding, each variable gets its own log. So that's the u, and the 2 went out front. And then the 4 goes out front here for the v. And this hurts, man. It's really early in the morning right now. Okay, so that's that for the first page. If I make any mistakes, just fix them. Alright, so for this one, it's a major exponent up here, so you can either distribute to each piece or you can take it out front. I'm doing these in different ways, just so you can, hopefully, at some point you're going to realize that you can do it either way, and what's equivalent to what. So, and then finally, so the big parentheses go around everything that v is negative. Sorry, it's 4 log v. Okay, and that 2's on the outside, but the 2 could also be distributed in on the inside, here, here, and then making that a -8. So again, this is negative here because the v to the 4th is being divided, or it's on the bottom. So this, you can put this 4 up there and combine these all, log base 6, x to the 4th, y, z, and put this big 6 up on the top. Or you could have just distributed all through. Okay, so that 1/2 goes on each one of these. So it's log of x, y to the 1/2. And this is log z to the 3rd plus. So when you add them, it's log base 2. So when you add them, log base 2 of z to the 3rd, you're going to multiply, and remember, 1/2 is the same as the square root. Right down here, you have to find the domain, range, equation of the asymptote, the end behavior, and sketch the graph. State all the values the graph is undefined. There's a lot of stuff happening. So remember, the asymptote is when this is equal to 0. You should be able to do all end behavior for this without actually graphing it, but we'll graph it first because I guess it's easier. So remember, x equals 2 is the asymptote. This is a poor, should have had more values here to graph, but the graph is poor. You have no room, nothing working over here. You're not doing anything, but whatever. So plot a few points. I'm going to come back and plot them. I'm going to plot them and then go through this stuff. Okay, so unfortunately I cannot fit more than 2 points on here, but you plot the 2 points. Remember, the graph, you know, is like a little curvy thing. Arrows should be on this side and this side. So the end behavior, well, we'll just do the domain first. The domain starts at 2, goes to infinity. The range is everything. Sorry, this was the asymptote. The end behavior as x, goes to infinity, y goes to infinity. And as x goes to 2, remember that's the asymptote, y goes to negative infinity. I think that's it. Sketch the graph. Perfect. Okay, write it each in exponential form. So all that means is do the log switch. Oh my God. I'm going to punch someone, not you. Okay, so do the log switch. That's what I call it, where this is the base, this is the exponent, and that equals the value. So b to the a equals 94. And then doing it the other way around, you have, this is your base. It's equal to x, and the log is always equal to the exponent. So it's log base 18 of 160 equals the exponent. Sorry. Okay, evaluate each. So you could just put this in your calculator, but we'll do it the real way. 2 to the x equals 32. So 2 to the x equals 2 to the 5th. So x is 5. This one, 2 to the negative 3 equals x. Just evaluate that. 1 over 8 equals x. So here you actually have to solve. So we're going to solve these. So remember, this is base 10. So it's 10 to the 2.369 is equal to what? 10 to the... So x is 233.9. And then we just solve the rest of these. So you have to be able to do the log switch first. So this is the base to the exponent equals 64. This is just a plain old number. If this was some sort of expression, we couldn't be doing this. So this is 1 to the 6th, 1/6. This is, so it becomes x minus 3 equals, I'm going to go with 2. This is 6. So we got to do plus or minus. So it's x minus 3 equals 2. X minus 3 equals negative 2. So x equals 5. And x equals 1. Okay, but if we do a quick check, if I put a 1 right here, 1 minus 3 is negative 2. Negatives are bad, so this guy is rejected. 5 minus 3 is a positive 2, so this one's fine. So 5 is your answer. All right, and then this one, we have x minus 3 squared equals x plus minus 1. So x minus 3 squared, as you all know, is this. So then we bring these guys over. Sorry, this stylus is making a lot of noise. So then this would be x minus 5, x minus 2. T-charting those out, x equals 5, and x equals 2. Check those. So if I check 2 in the base, 2 minus 1, 2 minus 3, excuse me, is negative 1. So this guy isn't going to check. Put 5 in here. 5 minus 3 is 2. That's good. And then 5 minus 1 in there. So everywhere there's an x, you should check them and make sure they're positive here. And this one, it has to be greater than 1. Find the inverse. Remember the inverse, we switch the x and the y. All right, this x minus 7 is not attached. I have to isolate this part first. So I'm going to add 7. So it's x plus 7 equals log base 3 of y. And then we do the log switch. So it's 3 to the x plus 7 equals y, and there's the inverse. We solve for y, so we're done. And then this one, x equals 2 to the y plus 5, switching the x and the y. Got to get this by itself. So I subtract 5. X minus 5 equals 2 to the y. And now we do our log switch. Log base 2 of x minus 5. Now this is the whole thing, so you need parentheses there, equals y. That's the inverse. Alrighty. Have a good day.